All right, polynomials, you should be familiar with that term or heard of these before. Here's kind of the standard form for a polynomial. Is going to be where this representation shows with the decreasing powers that when you write it in standard form or write any polynomial in standard form, you're always going to begin with the highest power, and then you're going to work your way down all the way till you're left with just constants. And now, one of the things that sets a polynomial apart from just an expression is that this n value, this power, has to be a whole number. It can't be a fraction, a decimal, a negative, a radical. It has to be a whole number, which means it has to be 0, 1, 2, 3, 4, and so on. Okay. So if I were, first of all, just entering the following. Okay, so if I had these expressions, each of them individual expressions, and I asked you to identify which ones are, in fact, polynomials. Okay, would 1/2 x be a polynomial? Does it fit this form where, again, we're only dealing with a single term, so it's not a big deal. It doesn't have to be in standard form, but is the power of your variable a whole number? What is the power of x? 1, is that a whole number? Yeah, so that is a polynomial. What about the second one? The square root is a power of what? Square root means x is taken to the power of 1/2. So is that a whole number? No. So that's not going to be a polynomial. What about 2 over x? Here x is to what power? -1. So that's not a whole number. What about x to the -2? Not a whole number. And x to the 0.5? Not a whole number. So the only one that fits that would be the very first example. ACT tests may likely ask you some kind of question referring to the definition of a polynomial. Usually it'll refer to the fact that its power has to be a whole number. The other thing when you're looking at this standard form, the standard form writing it from highest degree to lowest, or highest power to lowest, is referring to a concept called the degree of a term, and compares to the degree of a polynomial itself. Anytime you hear the concept of degree, the degree of a term simply means its power. Or if you have multiple variables, the sum of powers. So if I gave you something to the effect of 5x to the 4th minus 2x squared minus 3x plus 1. So here's our polynomial. It's written in standard form already. If I wanted you to identify the individual degrees, each term has a degree, and that degree is its power. So this term is a 4th degree term. This one is a second, it's the power. Has nothing to do with its coefficient. This one is a first. And then any constant is really just a power of, if there's no x there, it's a value power of 0. So that's how it's referred in its degree as well. It's a 0 degree term. So any constant is a 0 degree term. Now when you're referring to the degree of a polynomial itself, the entire polynomial, then you're going to look at whatever the highest degree term is. So the degree of the polynomial itself for here will be whatever its highest power is, in this case 4th degree. And now what it means, the only other thing here to discuss is what it means for sum of powers. And if I had a term like this, 3x cubed y squared, then the degree of this would be the sum of the powers, 3 plus 2. So that would be an example of a 5th degree term. Again, very basic concept, very easy concept once you understand or have seen what it actually means.